friends, so today we are here with a problem where we are to find the depth of neutral axis and stress in the concrete. So the problem is a beam 250 into 380 mm, that is the size of the beam we are provided here, to the center of the reinforcement is reinforced with 318 mm dia bar. So we are here provided with the size of reinforcement. Maximum permissible stress in the steel is 140 Newton per mm square. Here we are also provided the permissible stress of the steel, and we are given the value of modular ratio to be 13.33. Now we are to find the depth of neutral axis and stress in concrete, assuming the maximum stress is reached in the steel. So the value of sigma st is 140 Newton per mm square. Okay. And the value of modular ratio here is 13.33. Okay, so let us visualize this with a diagram. So this is a beam. So this is a beam where we are provided here with the 3 reinforcement, all of size 18 mm, and the width of the beam is 250 mm as provided in the question, and the effective depth is 380 mm as mentioned in the question. Okay, so here n is the depth of the neutral axis, and ct, which means the stress of the concrete around the steel, will be equals to T by M. T is nothing but the permissible stress of the steel in tension. Okay, so let us proceed with the question. Here we know Ct is equals to T by M, where T means nothing but sigma st divided by modular ratio. The value of the sigma st provided in the question is 140 divided by the modular ratio, which is 13.33. So what will be the value of this? The value would be 140 divided by 13.33, that is equals to 10.50. Okay. Now taking the moment about neutral axis, we'll be just dealing with this portion. All right, so the width of the concrete here, this is what? B. So we can write B into the area, for the area B into N, into what will be the depth here? That will be the half of the depth of neutral axis, that is N by 2, equals to, now we are seeing this section. So what we can write here is modular ratio into the area of steel. This is for the reinforcement section. M into AST into effective depth minus the depth of neutral axis. So what we can write here is 250 into N by 2 equals to 13.33 into 3 times of, there is 3 diameter, all of 18 mm, so 3 times of pi by 4 into d square, that is 18 square into 380 minus N. Okay, now on solving this, so on solving this, 250 into x by 2 equals 13.33 into 3 times of pi by 4 into d square into 380 minus N, that is the x. So on solving this, we are here provided with the value, that is x is equals to 139.82 mm. Now Using the similar triangle, C by N, okay, we are here first dealing with this triangle. So we can write here is C by N is equals to the lower triangle. What we can write here is CT divided by D minus N, or C by the value of neutral axis here we have already found. Sorry, this is not X, this is our N. 139.82 is equals to 10.50, which we have already found, divided by 380 minus 139.829. On solving this, we can find the value of C to be 6.11 Newton per mm square, which is nothing but the stress in the concrete. Now let us move on to another problem. So the problem says a singly reinforced RC beam of dimension 300 by 400 mm. So we are here provided with the size of the RC beam, that is 300 by 400 mm, to the center of reinforcement. Here to the center of reinforcement means the depth that we are provided here, that is the 400 mm, is to the center of the reinforcement. Here we can see that this is the center of the reinforcement and the depth provided here is this, and it is reinforced with 3 12 mm bars. Now we are here to calculate the moment of resistance of the beam if the permissible stress in the concrete and steel are provided as 7 Newton per mm square and 230 Newton per mm square respectively. Now what we can do here is we can find the modular ratio. So what we know is modular ratio is nothing but 280 divided by 3 times of sigma CBC. Sigma CBC means the permissible compressive stress of concrete due to bending. So it will be equal to 280 divided by 3 times of the permissible stress of concrete that we are provided here is 7. So the value here is 280 divided by 3 times of 7, that is 13.33. Now we can take the moment about the neutral axis like we did in the previous question. So what we can write here is taking moment about neutral axis. So again what we can do is we can write B into N times N by 2. This is for the concrete section, and then that will be equals to M modular ratio times the area of the reinforcement into D minus N. So this will be equals to 300 into N into N by 2 equals to 13.33 into area of steel, that we can write it as 3 times of pi by 4 into D square into 400 minus N. So on solving this, we can find the value of N to be 300 So the value obtained here is n is equals to 95.775 mm. Since we are to find the moment of resistance of the beam, we can clearly see that the question says here to calculate the moment of the resistance of the beam. But to calculate the moment of the resistance of the beam, we have to first determine whether the section is over reinforced or under reinforced. So, as we are to find the moment of resistance, we need to first determine whether it is over reinforced or the section is under reinforced. The criteria for the section to be over reinforced is the value of the depth of the neutral axis will be greater than the critical depth of the neutral axis, and for the section to be under reinforced, the value of n will be less than the nc. We know nc is equals to n1 times d, where n1 means m divided by m plus r and r means t divided by c. So t is nothing but sigma st and c means sigma cbc, which are the permissible stress in steel and the concrete respectively. So the value of sigma st that is provided in the question is 230 and the value of sigma cbc is 7. This is equals to 32.85. So now we can find the value of n1. So that will be equals to the value of modular ratio, that is 13.33, divided by the summation of modular ratio 13.33 plus r that we have found below 32.85, and this value will be equals to 0.288. So the value of nc now will be equals to 0.288 times d, that is the 400. Now we get here 115.2 mm. We can clearly see here is the value that we obtained here. The value of n is 95.775 mm, but the value of nc that we obtained here is 115.2. So what we can write here is, since n is less than nc, so this is a under reinforced section, and since this is the under reinforced section, we will be using the expression of moment of resistance for the under reinforced section, and that we know to be T into AST times D minus 1/3 of n. So T is nothing but the sigma st that we have provided here is 230 into AST. That means again the same. What we can write here is 3 times of pi d square by 4. So d square means 12 square into d, that means 400 minus 1/3 of n, that is 95.77. Alright, now on solving this, what we can get is and the value here is 28.72 kilonewton meter. So this is all for today. We'll be discussing more problems on working stress method in my coming lecture videos. So thank you.